Hey everybody, welcome to part 2 in our 2-part series on Jeep XJ wiring. Thanks for joining us again on Workshop Quick Takes. Today we're going to look a little closer at the means and methods that were used to put lights into a Jeep. And in this case, we'll be showing you things like Delphi connectors, Deutsch connectors. What are your options on those? Why would you choose one or the other? Are they really that hard to use? Well, not really. You just need to get familiar with a couple of crimping tools. So let's go back into the workshop and start taking a look at what you need to do in order to get your wiring neat, clean, and reasonably fireproof. Something that may not be communicated in snappy video tutorials is the planning required to execute a project successfully. But haste is the enemy of all projects, especially where electrical wiring is involved. It's an easy trap to fall into. Wiring is often one of the last tasks to get a project completed, and this here feels like action. Something is getting done. And this here, well, unless you enjoy technical illustration as much as we do, it can feel like wheel spinning. Different people have different levels of need for diagrams. Some people can track most of a project in their head with just a few scribbled notes here and there. But unless you know from experience that you are one of those people, you will probably get the most satisfying results from taking a minute to pre-plan your layout. Good wiring uses sensible routes through the vehicle, often by following the path of factory looms. The right wire gauges and fuses should be selected for the wire lengths and the loads that are being carried. Connector placement should be optimized to simplify future maintenance. A careful approach will help minimize the need for unexpected splices, which should also be planned and located only in reasonable places. Okay, one of the first things you need to think about is, what diameter of wire do I need? If you're in the United States, it'll be the American wire gauge for the most part. Somewhere in between 8 gauge, which you might use for certain high current applications, including auto amplifiers, and 16 to 18 gauge, which looks more like this, you need to find a size that fits your load profile. Obviously, there's current flowing through the wire, and there's resistance in the wire, and that becomes effectively part of the load. And so by the time I get to the actual load I'm trying to power, some of the voltage has already dropped off because it's done work heating that wire. Also, how long is that wire? Because the farther the current flows through the wire and the higher the current, then the more voltage drop you're going to get. You also need to be thinking about, hey, is this a load that it's only going to be available when the ignition is switched on, meaning the alternator is most likely running and you've got a steady 13.8 volts, or is it something you want to be able to run off the battery? Because if it runs off the battery, it needs to tolerate about 11.5 to 12. Now, you could get your own copy of the National Electrical Code and start thumbing through Chapter 9, where we have all these nifty tables that start covering different wiring sizes. But instead, I just went onto the internet and searched auto wiring table, and this was one of the first links I got. And it's an interactive table where I have total load amps on the left-hand column here, and I have conductor length across the top, and then I just pick an ambient temperature. It starts at 20 degrees C by default, but you can go 40 to 100, and then you also pick your conductor voltage drop you're willing to tolerate, 5%, 3%, 2%, and you can also then make a decision whether it's a feeder conductor. Maybe it has multiple subloads coming off of it. What this is basically telling you is it's not just current that matters. You have to account for how hot it's going to start out, because there will be a temperature rise on the conductor as current flows through it. But if it's in the engine bay, it's not going to be starting at 20 degrees C for most of its life. It's going to be running hotter than that. If it's mostly running through the body, well, maybe you're better off with a lower temperature. You live in a cold climate and do all your wheeling there? Hey, that's great. Do it in the desert? Well, again, think about a higher temperature. Let's just suppose I'm going to go with a conservative estimate of 50 degrees C, and I've got a 20 amp maximum load, and I want to run it for 10 feet. Well, this is telling me I should probably be using a 12 gauge wire. Keep in mind you can always go to a larger size and get less voltage drop and cooler operation, but then you end up with a fatter bundle of cable. And depending where you're trying to run your wires, sometimes if you get too many wires that are too thick, they become heavy for one thing, and they take up more space. Once you've sized your circuit conductors, don't skip over to the fuse even if you don't have a fuse holder handy. Don't get in a hurry and try and just light everything up without them. Remember that your automotive electrical system can deliver a few hundred amps into a fault via the battery, and that will burn something. It's just a question of whether it's a cheap, easily replaceable fuse or some expensive and annoying switchgear and wiring. And even if you don't actually burn the vehicle down, if you destroy a major electrical harness in the vehicle, it might be enough to total the vehicle. Pick your fuse sizes so that they can carry the full load current with a little bit of margin. That way, if you're starting up loads that have inrush, you're not at risk of eventually nuisance failing the fuse. For example, if you've got a 7 to 8 amp load, then a 10 amp fuse might be more than enough to handle it. But if your load is pretty close to 10 amps, consider upsizing your circuit and the fuse rating to carry 15. Okay, there's a quick and crude sketch of the front of our Jeep, and the notable feature here is this front clip piece. This is removable. So to understand why and how we should be putting connectors, let's consider what we might have to disconnect later in order to service this vehicle. Down here, we have a pair of trail lights. And then up over here was the new electrical box we talked about adding last time. This has the actual relays and the feeder harnesses that connect out to the front lights and to the rear. So let's just go ahead and sketch those like this. To front lights, to rear lights. Now, in order to decide where we should put inline connectors on this setup, we need to consider serviceability. In the case of trail lights that you can buy, in this case from Harbor Freight, sometimes they will come with an inline connector, and these come with this connector nicely molded and pre-terminated onto the light. And then there's this pigtail one here, which goes out to whatever you want to connect it to. So the question is, where do we need more connectors like this? Well, we've already got one here, and this makes sense. Because right here and right here, we have these lights mounted on the bumper. So that's the first two places we have connectors. So if we need to remove this bumper only, and the lights are going to come with it, then we can unplug the two lights, remove the bumper, and it doesn't affect this harness. However, the way this harness is wired through on my XJ, it actually comes under the front clip right here and follows the other lighting harness. It's a good place to attach it. But that means if I need to remove the front clip, I need another disconnect over here somewhere. And so here right below the battery last time, we briefly showed you there was a Delphi connector here. These are the three most logical points to offer disconnects, because I can disconnect here and remove the bumper, I can disconnect here, here, and here, and remove the front clip, and then this harness, which is tied into it, comes off with it. Now, going to the rear lights, in this particular case, I chose not to have another such connector coming out of here going into the cabin, because this box is not going to be removed. And in the unlikely event it is, then the little connectors that come up in here underneath the relays and the fuses can be unpinned from the box, and then the box can come out and just leave behind the wires. So coming up with something like a scheme like this is important to think about when you're designing your lighting circuit, your auxiliary compressor circuit, whatever else you're running power to. Usually you do want at least one point where you can unplug it so that the device itself can be removed and serviced. However, you don't want more connectors than is necessary to make it serviceable, because each one of those additional connectors you add is another potential failure point in the future. In part 1 and now in part 2, we have been and will continue to talk a fair bit about types of connectors. If you're not already familiar with them, there's two popular kinds you can get. One is the so-called Delphi connector style, and the other is Deutsch. You can order these as little single kits or as boxes of kits from various vendors on eBay, Amazon, anywhere else online you care to shop that has electrical components. The Deutsch connector is this style here. This particular one is a 2-pin, and this is what it looks like when it comes as parts and pieces. There are 2 main body connectors here, 3 weather seals, 2 locking pieces, and 4 pins associated with a 2-pin Deutsch connector. We have 11 pieces total, and it uses an alternating male to female, female to male design. You terminate your pins, and then they go down in here and lock. And these are the female pins, but once this is all snapped in, they're inside the male connector. So the male connector plugs into the female connector, but the female connector, in turn, has the male pins inside. Looking at this light, you can kind of see that. This one here should see the barrels of 2 female connectors glistening inside the plastic male connector. And over in the plastic female connector, we have a glint of 2 metal male connectors. So it's a very nicely interlocking design, completely weather sealed once it goes in, and should hold up very nicely. The counterpart is the Delphi connector. This one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 pieces. The reason you might choose the Delphi over the Deutsch, assuming you don't have any space concerns, is that this one uses larger pieces that are easier to assemble. The Delphi connector uses the same philosophy as the Deutsch connector in that the male plastic connector has the female pins installed in it, and the female plastic connector has the male pins installed in it. Very similar current ratings available for each type. Now, with the 2-pin designs, the size, not much different. Where it gets interesting, however, is when you start getting into higher pin densities. Here, for example, is a 6-pin Deutsch connector. And with slightly higher current ratings, but otherwise in most cases identical, here is the construction of a 6-pin Delphi connector. This here is a large, awkward device. It takes up more space wherever you're planning to put it. Cost-wise, they're about the same. Normally your wire is seated just like that. So there's a length of stripped wire that's between these two lower tabs, and then a length of unstripped wire between these two longer tabs. What you need for this is a crimp that has a double die on it. And what you're better off doing is getting a kit for about, I don't know, last time I looked, these were about $50, $60, but one that has interchangeable dies. So this one here has 5 different options. This one here with the familiar red, blue, yellow color code on it is for insulated ring spade terminals, things like that. But the one we want is this here. Looking here, you get a real good example of what the double die crimp is. And again, looking at the bottom side, this piece right here is responsible for crimping around the wire, and this piece here is responsible for crimping around the strain relief on the insulation. Going to this side, that one there folds and wraps the top pieces, that one there folds and wraps the bottom ones. So let's see how that works. In order to use this particular one, what you do is you have to press in this little piece right here, and then that slides and locks. Same thing for the bottom piece, slides and locks. This one here has the release, so if something bad happens mid-cycle, you can get out of the situation. So let's just start from scratch. We have a piece of wire. We need to first feed it through the weather sealing if we're doing the Delphi connector here. And on this connector, the pins feed in from the back side. That means, since this connector is the one that has the male plastic but takes the female terminal, I need the female terminal, and that's what I'm going to have to crimp. I'm going to need to be looking at the right size one here. It's probably going to be this here. So what I need to do is I need to get this very neatly lined up in here so that it's trapped. And that's the nice thing about having the rear terminals that wrap around the insulation being a little bit longer, is I can start this like this, and now it's locked in there. It's not going to fall out and drop around. I probably need to put just a little twist on my wires here to make sure they don't splay out in there. Slide those in until I have the insulation, but only just. I don't want the insulation to go past. And then full cycle crimp. And unfortunately, that wire is just a little bit too small. However, that does give us a little idea what happened there. All those little tabs folded in. But let's see if we can do that correctly. So I'm going to try re-crimping this on a smaller size and see if that fixes it. I think it might need to, actually. It doesn't look like even any of these really went around the way they were supposed to. There we go. That's what it's supposed to look like, more or less. Remember, it shouldn't pull out with a tug. And then the last step here is I need to go ahead and feed this in, and I need to figure out which way that fits up in there. This is one thing that's very important to pay attention to on the Delphi connectors. You could attempt to install these backwards, and while they won't snap and lock in correctly, you might be able to force them in there in a way that feels like it fits. Okay, snapped and locked. And then the weather seal pushes in. Just like that. So let's go ahead and do one more the same way. Strip, light twist. I probably should have brought the weather sealing connector up first, but that's okay. We're good on this one. I have my other pin. Go ahead and get that locked in place on the correct one this time. Slide the green one in so that the copper comes right to the edge there. Full cycle crimp. Wire secure. That one turned out really nice because I got it right the first time. And then snap and lock. And if I need to, I can always just push these in a little bit farther because they have some play up in there. To the Delphi connector on the other side, it's going to be the same procedure. Here I'm going to do something different. I'm going to change colors going across the connector. So I went ahead and made sure that white matches up to white, but for whatever reason I've got green on this side and now it's going to come out black over here. That's fine. Just make sure whatever drawings or diagrams you put together, keep track of that. Final step on both these connectors, this little thing. It's kind of agnostic to which side it goes on because the connector is perfectly symmetrical down here, but one way or another, it's generally just good to be consistent which way they face. So let's just say that this side is going to face the tab side. Done. Done. We now have a 2-pin Delphi connector to a 2-pin Delphi connector that plugs in like that. Does it work? Well, let's do a continuity check. If everything went as expected, we should be able to set this to continuity test. Okay, the meter tests against itself. White wire on one side should have continuity white wire on the other. It do. It's not a very scientific test, but I'm certainly not seeing any resistance on there whatsoever, which should mean we made a good connection through for now. And then green should go through to black. And it do. So we have one complete Delphi connector, and if we want to open it up, remember this style, tab lifts to unlock, and then they separate. Alright, now let's try out our Deutsch connector. But just to make this a little more interesting, let's suppose that I've got a loom going down to somewhere, and now I get down to a location where I need to make another connector. At this point, it shouldn't surprise you too much to learn that the Deutsch connector assembly is pretty much the same as for the Delphi. The wire entry weather seal for the Deutsch is shared by all wires, but you still need to feed the wires through the seal, strip a 1/4 inch or so, crimp the pin, and then insert the pins from the rear side of the connector housing until each snap locks in place. The Deutsch pins are round, so you don't have to orient them before installing, which is nice. There is one crucial difference though, and that is how the locking mechanisms are applied. And then on this one, the locking mechanism is this other green piece right here. And the way that's going to go in, it's going to go in right there, and when it does, it's going to bind those two tabs so they can't release. This prevents the pins from popping out. Took a little bit of force, but now it's in. Weather seal, in like usual, and they just kind of loose and flop around until you install the locking mechanism. And that one does go in with a little bit of a push. So yeah, there you go. It can be a fairly tight connection, fairly tight to do and undo, especially when the seal is new. If you have some issues with it though, there is an easy solution for that. This here is Glide. It's a silicone-based lubricant, and you just need a very small amount of it on the new weather seal here. And once that's on there, that should clean up a bit. Let's do a continuity check. Self-test the meter. Meter good. I'm now expecting black on this end to come all the way through to black on this end. Hit do showing no resistance, that's good. And white on this end, I'm expecting to come all the way through to blue on this end. Hit do again with no resistance. One final check. I don't want to see cross continuity between the two conductors. It does not appear that I do. So that's the basics of assembling Delphi and Deutsch connectors. If you have one that's more than 2 pins, it's the same procedure. You just have more things to crimp, and then you need to make sure that you track more positions through the connector to ensure that what goes in on this side is what you expect to come out on this side. Okay, if you've been following my costume changes up to this point, you're probably getting the idea that this is kind of a long process, and you are right, wiring is tedious. Now that we've explained wires and fuse sizes and how to terminate connectors, does that mean you're ready to go start pulling wires in your vehicle and then putting connectors on the ends and away it goes? Well, no. There's one more step you need to be aware of in order to make a well-protected wiring design, and that is protecting the wires from chafing and vibration. If you don't do this, sooner or later you are going to have something that is cracked or chafed through, short circuits, maybe it's constantly popping fuses, maybe it melts ground return paths, maybe it starts a fire. So stick around for just a little longer, and we're going to cover the last step you need to know in order to safely bundle and route your cables. While we had you distracted, we snuck back into the workshop and added a few ring terminals to our demonstration harness using yet another variety of full cycle compression tool. This one is available for about $20 at Home Depot. It does not come with interchangeable dies off the shelf, but if you mainly work with the common red, blue, yellow compression terminals and splices, it's well worth having. Alright, once you are done working with connectors and figuring out how you're going to lay those out, you're going to need to start figuring out how you're going to bundle your wires together. Now, you may end up actually doing some of these steps out of order because you need to pull long lengths of wire through firewalls or around through sill rails or things, and that's fine too. There are 3 types of tape you could be using. First one here is a self-adhering silicone tape. You can get this at most hardware and home improvement stores I've found these days. This stuff is really nice, but it's also really bulky, and it has no damage resistance whatsoever. I mean, if anything sharp hits it, it just sort of goes through. Another nice one to have kicking around is this cloth tape. This is sticky on one side, it's cloth on the other. This stuff is more expensive, I've found. I mostly like to use this in areas where I want to reduce noise from something that might be rattling around a little bit and make sure it's not vibrating and something going clack, 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 clack. So this here is good for that purpose. I don't like to use it for general purpose wiring. I've seen some YouTube channels where they seem to use nothing but this stuff, and it's like, how do you afford that? Because Ordinary electrical tape can actually get the job done in many cases, and I always use the Scotch Super 33 Plus when I can. It only comes in black from what I can tell, but this is an extremely soft, very friendly, forgiving, flexible tape. I really like to use it. It has a wide operating temperature characteristic, so it doesn't, go stiff and crack and brittle at low temperatures right away. Great stuff. Bundling your wires together usually means taking short lengths of electrical tape and just wrapping them like this. Every foot, every 3 foot. I mean, if you coil up large bundles of wires, especially if you have 3, 4, 5 bundle of 8, or just letting them lay around the vehicle as you try to route them, if they're not bundled together in logical groupings, that's when you're going to have problems because they're going to tangle up. You probably wouldn't bundle one like this 3 times like I'm doing. It's such a short little length, but this is just for illustrative purposes. So that's the basic idea. Now the wires are grouped together, they're not going to flop apart, tangle with other things. And since we've done one, let's just get these others done real quick and then we'll continue. Let's suppose now that I've got this little auxiliary harness that's traveling in parallel with this one, but right here, in the middle of these 2 points, it actually needs to split off and form an actual T. So whatever the source is that these terminals are going up to, maybe it's some kind of terminal block assembly, right here, they're still traveling in parallel, that's fine. But then I get to right here and they need to split. So first off, let's just get another piece of tape wrapped around them right at this reference point. The blue and black wire is going to travel along whatever it's traveling along. Red and black splits off in a hard T. And usually just clever taping will help ensure that there's never any undue tension or stress at this point. So now, instead of just pulling off a piece, I'm just going to start with the whole roll. That there's my T-junction. And make sure if I yank on this that I'm not just yanking on the wire against a tight junction, it's going to sit here and tug on the tape instead. So now you're kind of getting the idea of what these looms start to look like as they take shape. One thing you will find in commercial applications is they may actually do a wrap around the wires just to hold them all together, as well as provide some external protection. So this is something you might see. And if it looks like it's useful in the area where you're trying to do it, to keep wires from flopping around so they have just a little bit of extra protection against chafing, go for it. Another instance where you'll see this done is at exit points from other types of protective sleeves and wraps. Now let's suppose it needs some outer protection also. You have a few different options for that. There's split limb tubing. It comes in large sizes, small sizes, every size in between. And then there's also this wrap material, which I found at the auto parts store, but I'm sure you can order it online as well. And it just wants to stay curled up. So you have to kind of like pull it out, get your cable tucked in there, and let it wrap back around again. So let's start with split limb tubing. And since this is a really small diameter, we can work with a fairly small size here. But we are going to need to measure it out. So let's suppose I need to go all the way along here. Now this stuff just pops apart like that. If you've already used it before, you're familiar with that. Work it on at one location, and then just force it on by pushing it back like this. Where it will give you some trouble yet is when you have any of these T-junctions, so you need to be aware of those, but that's okay, we'll just work past it. Once again, I'm going to take the electrical tape. At this T-junction, I'm going to wrap it on both sides so that it never walks its way back off of there. Now there's about as secure as it gets, but on the ends, there's a chance you'll want to do the same thing again. And maybe even come up around the wires for a short distance just to make sure they don't walk away. There it is. Now if I had concerns about these, I could wind tape around a little bit more here and here, but most of the time, this is about what you need to do. But supposing you had split loom going along a real long section here, you're going to want to do the same thing that we were doing to bundle the wire earlier, just to make sure the split loom doesn't pop off later. And that is just go along it at periodic distances. You know, a few inches, 12 inches, whatever you're comfortable with. It looks like it's going to hold it all together. And just put a little tape wrap around it. If for some reason you had concerns about the location of the loom, you could even take the electrical tape and just wind it all the way around it along the length of it like we were doing here. But for the most part, these kinds of methods are the basis of good, solid wiring. Okay, let's just quickly summarize the techniques that are now demonstrated on here. From here to here, the loom is tape wrapped internally and then has split loom tubing over it. So that gives you maximum protection when it's required, but it uses the most materials. From here to here, we just have the bundled wire inside and we have the split loom over it. This is usually good for traveling long distances where you're not worried about things moving around at all. So this here you want to do at the end of the harness where you've got other connectors. This for traveling long distances. Here we use the wrap loom. This is good if you need maximum flexibility for getting around an obstruction. You can also decide whether or not you want to tape wrap the wires inside that. The more materials you add, the less flexible it gets, but the more protected it is, so make that trade-off. Here we're just using electrical tape along the loom to secure a T-junction and also just make sure it doesn't unwrap itself later. At the ends we've wrapped. Here I've wrapped with electrical tape, here I've wrapped with cloth tape. This here, cheapest materials and very effective. This here, more expensive materials, but quieter. So if it's in a place where it might rattle against other materials and cause annoyance, especially in the cabin, you might want to think about doing more of this where it makes sense. Here we've just got open wires that are just bundled. Normally you don't want to route anything like this unless it's, say, through another loom where it's tied into another bundle of wires and isn't rubbing or brushing against anything. Otherwise, you can go with just the basic tape wrap for an added layer of protection or to secure accessories like this little push rivet connector here. And then when you get to the ends, you do want to leave just a little bit of a flexible tail so that the connector doesn't have any issues. Okay, this here is a door from a 2000 Jeep Cherokee XJ. Everything has been stripped off of it except a little bit of the internal hardware, and this is typical of the types of edges and raises and tack welded things that you'll find inside almost any body panel in this vehicle and many others besides. So it's a good place to demonstrate some wiring technique. And again, this wiring was also made up for demonstration purposes. One of the most common hazards you'll find when running wiring is a fairly sharp edge like this. One of the easiest ways to provide protection before running a wire around an edge like that is just to use some of the same split loom tubing you were using inside and do that. And if necessary, just add a piece of heavy tape like duct tape or Gorilla Tape or something that's not going to easily just peel right back off. Now that's generally safe to run almost any type of wiring around, but at minimum, you want them tape wrapped. Tape wrapped wiring is usually fine for running adjacent to body panels, and in some cases that may be exactly why you put one of these rivets on. And then that wire, if necessary, would go over like that. Another option you might not have thought about before, though, is this trim. It comes in both black and chrome, and it's often used to just put edges on doors and things, but it turns out it's really, really good stuff for protecting sharp edges. Some of them come with a little bit of glue liner inside them there, and I think this one does too, so that helps with securing it on. Bingo. Very good protection for wiring going around sharp edges. And because it has that little glue in there, if you press it on, maybe heat it with the heat gun briefly, it's not going to pop back off too easily. So those are things to think about also when going around edges. And then when you're running through panels, generally if you have split loom on it, or at least a tape wrap, depending on where the location is, you just want to make sure that wherever you run it and secure it, you watch for hazards. For example, this is a door, obviously. There's a window that comes up and down in here, and it runs down this track. Now when it comes down the track, if you look in here, you can see that it's fairly far back in there. So there is some space up in here where you could put a couple things and they wouldn't be interfered with. Now, whenever using what appears to be a conveniently placed factory installed hole, make sure it's not being used for something else. This hole here, for example, these are being used by factory wiring originally, which is why they're there. So if I'm making retrofits, I would already find factory wiring there, which I could probably just zip tie to. Other times you will find holes that are clearly not being used. They were either put there to help with the manufacturing process or for options your vehicle doesn't have. But if you get the locations right here, those you want to pay attention to because that's where the door trim card comes back on. And not only does the door trim card reattach to holes here, but it might interfere with some things that are sticking out here. So you want to do test fits before you really tie everything down tight. Last thing to consider while we're here is let's assuming this was an available hole that we could actually feed cables through. We might be able to do that if it's reasonable to do so. The split loom tubing will provide some protection, but when feeding large numbers of wires through holes, sometimes it's better just to go locate a grommet. You can often find those at your local auto parts store as a generic plug grommet, and then you just drill out the hole you need in order to make it work. So that's a few more things to think about when you are running wiring in a vehicle. Sharp edges should be protected, holes, use grommets if it's reasonable to do so, and make sure the level of protection on the exterior of your wiring matches the location you're running it. Everyone, thanks for joining us again on part 2 of our 2-part series on Jeep wiring. Hopefully you learned some useful tips and tricks, but hey, I'm in here and you're in wherever you're sitting right now, but your vehicle's parked outside. So what are you waiting for? Go out there, make it better, make it yours, make it more useful for your needs. We hope that you gain something useful out of this, and we'll see you again next time, whenever that is. Has anyone seen my phone?